I would like to start with thanking the organizational committee of this conference for this opportunity. My name is Muhammad Abu Ali. Currently, I am the director of the Clinical Engineering Department at the President Ilyas Hrawi Governmental Hospital. Also, I'm a part-time instructor at the Lebanese International University, the LIU. Hospitals are considered among the most expensive buildings in the world. For example, in 2016, the new Royal Adelaide Hospital in Australia was considered as the third most expensive building in the world, with 2.1 billion capital cost. This is primarily due to the expensive medical equipment and the required infrastructure. For example, a PET MRI in the radiology department could cost between $3 to $5 million. Another example is a surgical robot, which is used in the operating theaters, could cost between $1 to $2 million. So, our topic today will be about the purchasing of the medical equipment and how to reach an informed decision. Recently, I have developed a tool which is an Excel sheet to help final decision makers in this purchasing process to reach such informed decision without the need to go in depth, technically, clinically, and financially. Now we'll start our talk about the knowledge required in order to purchase medical equipment. This includes the knowledge about technology, market, estimated life, cost, and finally, regulations and standards. To illustrate this, we will talk about the purchasing of a specific device, which is the flat panel digital radiographic fluoroscopic system, which is used in the radiology department. This device also known as the DRF system. Finally, we will apply the new tool in the purchasing of the DRF system in order to automatically calculate the scores of the bidders in this bid. In the part 1, we will talk about the knowledge needed in order to purchase medical equipment generally. Prior to the talk about the purchasing of medical equipment in hospital, we will talk about the clinical engineer, who is mainly responsible for the purchasing of medical equipment at hospital, starting with the assessment of the demands and ending with the purchase order. A clinical engineer is a professional who supports and advances patient care by applying engineering and managerial skills to the healthcare technology. The main duties of a clinical engineer include quality patient care, financial savings, consultation services, regulations, and standards. As a part of the consultation services, the purchasing of the medical equipment will be the main topic of our presentation today. The purchase of medical devices or systems in hospitals requires profound knowledge about the technology behind this device or system, in-depth knowledge of the market, which means the manufacturers, the models, the suppliers, and so on, the expected or estimated life of this device or system, the cost. What we mean by cost, we mean the initial cost or the capital cost, the installation cost, as well as the operating cost. Another requirement is the regulations and the standards related to the installation and operation of this device or system. The first knowledge which is essential to purchase a medical device or system is a full understanding of the technology behind this device or system. This means an in-depth knowledge and not a superficial one. We must know the main elements or components of this device or system because this will help us in the comparison between the different manufacturers. This will give us an idea about the quality of the components used in this device. We should know some knowledge also about the developing history of this device or system. In this slide, we see a collection of medical devices and systems used in hospitals. The second critical knowledge which we should acquire in order to purchase a medical device or a system is a complete and full awareness of the market. The market means the different manufacturers available in the country and also their local representatives, the suppliers and vendors. The knowledge of the manufacturers also should include information about their different models and the feature of these models. Also, we should have a knowledge about the suppliers or vendors. This knowledge should include the quality and the cost of their post-sale services. In this slide, we see some well-known manufacturers of medical devices and systems worldwide used in different areas in hospitals. The specialties include radiology equipment, which are the most expensive items in the hospitals, the laboratory analyzers, surgical devices, as well as other medical devices and systems. As everything in this life, medical devices and systems have an estimated life. The expected life or estimated life of medical devices and systems can range from 2 years up to 25 years. I have chosen a random group of 1,317 medical devices and systems from the Universal Medical Devices Nomenclature Systems, known as the UMDNS, developed by the IEEE Institute. These devices have been gathered based on their life expectancy. As we can see in the right diagram, most of these medical devices and systems have a life expectancy either a 7-year or 10-year or even 15-year. Another important information or knowledge is the cost. The cost doesn't mean only the direct cost or the initial cost which is required to purchase a medical device or system. The cost also means the installation cost and the running cost. In 2016, the hospital administration had asked me to prepare an estimated budget in order to renovate and replace medical equipment in 4 areas, which are the radiology, laboratory, intensive care unit, and surgical suite. The table in this slide was just a summary of this renovation plan for these 4 areas. As we said before, the cost should include additional to the initial cost or the capital cost, the cost of the installation as well as the operational cost. The cost information is essential prior to take the decision in the purchasing of the medical device or system. In this slide, you can see a room data sheet for a medical device. This room data sheet includes the works needed to be executed prior to install the medical device or system properly. The installation cost means the cost of the infrastructure needed. This includes the architectural and interior design, the communication and special systems, power, plumbing and medical gases, and finally heating, ventilation and air conditioning cost, which is also known as the HVAC cost. Some of the regulations and standards are voluntary, whereas others are obligatory and must be followed. However, in both cases, This will help the hospital team applying the best practices, which are translated in a better and safer environments for patients. In this part, we will talk about the flat panel digital radiographic and fluoroscopic system, which will be used an example of the purchasing of a medical equipment. The right diagram represents a functional diagram of radiology services or department in a typical university medical center. This functional diagrams represents the relation between the different spaces within the radiology department, as well as the relation of the radiology departments with other departments within the hospital. The radiological systems or devices can mainly be separated into three main categories. The first one is called the anatomical category. The second one is a physiological one, and the third one is a hybrid system. The anatomical devices or systems, such as computed tomography scanners, also known as CT scanners, are characterized having high resolution images with anatomical informations, whereas the physiological systems or devices, such as the positron emission tomography, which are also known as the PET scanners, are distinguished having a low resolution images with physiological information. The last category is the hybrid systems or devices, which are the most expensive, such as the PET-CT scanners, which is a hybrid because it contains two types of technology, which is the PET with the CT, which means the physiological information with the anatomical information. These systems acquire high resolutions of images containing both information about the anatomy as well as the physiology of the organs of the patients. The table in this slide shows the major devices and systems in the radiology department or services with their life expectancy, which means their estimated life, as well as their list price. The list price means the initial price without any type of negotiations with the suppliers or vendors. This price, we can have it if we ask for a proposal, which means not the final price or cost we will have for this device. These devices and systems in the radiology are considered among the most expensive items in the hospitals. The range of the prices can extend from $30,000 up to $5 million. The PET MRI scanner or system is considered the most expensive of these systems, with a cost range between $3 to $5 million, as we can see in the table. Due to this expensive cost without being justified clinically or without any value, justified value for the patient care, most manufacturers have stopped the manufacturing of these systems. Now we'll start our talk about the flat panel DRF system, which will be used for the application of the new purchasing tool. The flat panel digital radiographic fluoroscopic system, also known as the flat panel DRF system, is a diagnostic medical equipment using X-ray radiation in order to visualize the internal body organs. The cost of this system can extend from $200,000 up to $400,000 with a life expectancy of 10 years. Now we'll start our talk about the flat panel DRF system, which will be used as a model of the medical devices and systems in hospital for the application of the new purchasing tool. So what are the major components or parts of the system? The major components of the DRF system are a tilting table with a plus 90 degree tilting angle and a minus 90 degree tilting angle, a dynamic flat panel detector, an X-ray generator, an X-ray tube, an operator's control console, monitors, X-ray field collimators, as well other parts. The photo in the left is for a typical flat panel DRF system with its major components and parts. In this slide we can see the photos of major DRF system components or parts. The first image is for the tilting table with plus 90 degree tilting angle and minus 90 degree tilting angle. You can also see the operator control console. Another component is the X-ray generator. Also we can see here the image or photo for an X-ray tube. And finally we can see the image for the dynamic flat panel detector. In the past, most people used tungsten lamps to illuminate or light their house. In this slide, we see an example of 100 tungsten filament lamp. We need an alternating source, an AC source, to generate light using such lamps. In Lebanon, such sources come with a 230 operating voltage and 50 Hz operating frequency, and the current consumption is around 0.4 amp for each 100 watt lamp. In the case of the DRF system, in order to generate an X-ray, we need an X-ray tube instead of the lamp and an 80 kilowatt X-ray generator, as well as a hospital 80 kilowatt UPS power source. So the first question comes to our mind: why we need an X-ray generator and why we cannot connect directly the hospital power? To answer this question, we need to understand the requirements in order to operate an X-ray tube. An X-ray tube needs a current source, which is usually the cathode filament, to generate an electronic cloud. Then a strong electrical field between the cathode and anode sides of the X-ray tube is created using a high voltage source, which directs the generated electrons towards the anode with a high speed. This high voltage source must be a DC voltage source with a range of 40 up to 150 kilovolt. Also, we should know that only 1% of the X-ray power, X-ray tube power, generates X-ray radiation, whereas the rest of the power will generate or will be wasted as a heat. Thus, we need also to cool the anode side using a motor to avoid its damage. In this case, we used a rotating anode. Thus, all these functions are supported by the X-ray generator, which also supports other functions related to the tilting table, the operator console, and other DRF system parts. In this slide, we see a block diagram of a high-frequency X-ray generator which is connected to an X-ray tube. The X-ray tube of a DRF system requires a DC voltage with a range between 40 up to 150 kilovolt, whereas the hospital power source is a UPS system or uninterrupted power supply system, which provides us with 400 voltage 3-phase waveform. So we need to make a match between the voltage of the hospital source and the requirements for the X-ray tube. In the past, we used a high voltage step-up transformer with a variable magnification power between 100 and up to 375 times. Then we rectify the output of this high voltage step-out transformer and supply it to the X-ray tube. The problem with this high voltage transformer is its size. It's so bulky. To solve this problem, currently we use high-frequency X-ray generator as the one in this slide. So how does high-frequency generator work? In order to reduce the size of the high-voltage transformer, we need to increase the operating frequency of the AC source. So this is the solution for the above problem. So the increasing of the frequency of the source will minimize the size of the transformer. In Lebanon, we use a 50 Hertz AC source. So in order to solve this problem, we use inverters, which are a DC to an AC converter with an operating frequency between 20 kilohertz up to 300 kilohertz depending on the manufacturer. So first, the hospital UPS AC voltage is converted into DC form using a full bridge rectifier, and this energy will be stored in capacitors. Then we use the inverters, which will convert this DC voltage into an AC voltage with very high frequency between 20 to 30 kilohertz. After that, the high frequency voltage transformer, which also known as the RF transformer, is used to step up the voltage. Finally, rectification is done and supplied between to the anode and cathode sides of the X-ray tube. Also, we need to address another problem, which is the arcing risk due to the use of this high voltage. Usually manufacturers either use oil or evacuated pots to house this high voltage module and to avoid the presence or existence of the air around this high voltage system. This slide is just a recap of the previous slide. We have a hospital UPS AC voltage source, which is with an operating voltage 400, which means 0.4 kV, with a 50 Hertz operating frequency. Firstly, this input will be rectified using a full bridge. Then the power will be stored in capacitors. Then this DC voltage will be transferred into an AC voltage with very high frequency. We are talking about 20 kilohertz up to 300 kilohertz. Then we use an RF transformer, or high frequency transformer. Then the output of this transformer will be rectified and finally supplied to an X-ray tube, which needs an operating voltage, DC voltage between 40 up to 150 kilovolt in the case of the RF system. In this slide, we see a detailed block diagram of a high-frequency generator, a commercial one, which is manufactured by the Canadian SPI company. As for the inverter boards technology of the X-ray generators, we have two main categories. We have the resonant frequency and we have the variable frequency. We see in this slide a 300 kilohertz variable frequency inverter board, which is manufactured by the SPI company. This board uses MOSFET transistors as a switching elements. It has an operating frequency up to 300 kilohertz. It's supplied with 560 volt from the capacitors. The SPI company usually uses oil to isolate the air in order to avoid the arcing problem. Another also well-known and famous manufacturer of X-ray generators is the Spellman American company, which uses resonant inverting board technology and also uses boards to isolate air and avoid the problem of arcing. In addition to the in-depth knowledge of the RF system, we need to have a good knowledge and in-depth knowledge of the site requirements in order to install and operate the RF system properly and safely. These requirements are summarized in a room datasheet. These requirements include architectural and interior design, communication and spatial systems, power, plumbing and medical gases, and finally heating, ventilating and air conditioning, and this known as HVAC system requirements. So to sum up, the installation requirements of the DRF system includes the need for UPS hospital source, lead shielding of the walls and doors, medical gases, oxygen, vacuum and medical air, special room height to allow the tilting movement of the table, as well as other requirements. In this part, we'll talk about the purchasing of the DRF system and the application of the new purchasing tool in order to reach an informed decision concerning the purchasing of this DRF system. The first step in the purchasing process of a medical device or system in a hospital is to develop the specifications based on inputs from different departments and stakeholders. Here we can see in the table on the right the major points in the specifications for the purchase of a flat panel DRF system. There are 12 major points which need to be complied and filled by the suppliers. Thus, the suppliers' offers should comply and answer all these 12 points. The 12 points are the description of functions, operational requirements, system configurations, technical specifications, accessories, spare parts and consumables, operating environment, standards and safety requirements, training, warranty, maintenance service during warranty period, installation and commissioning, and finally documentation. Based on the supplier's offers, a comparison summary table and bid evaluation sheets will be generated. The comparison summary table should include a comparison between the major components of the offered systems, DRF systems. This should include a detailed description and features of each component. Also, it should include the information concerning the price of the main system and its options, such as the DSA, tomosynthesis, stitching, and so on, the warranty period, the validation of offer, as well as other information. The evaluation sheet will be separated into two main parts: the evaluation factors and their corresponding weights. The evaluation factors will be calculated from the comparison summary table, whereas the corresponding weights will be entered by the final decision maker in the purchasing process of this DRF system, which is usually the hospital manager. There are 5 evaluation factors: the compliance with the specification, the quality of the device or system, the price of this device, which is also known as capital or initial cost, the spare parts price, also known as operating or running cost, and the final factor is the delivery time. These factors are determined based on the information gathered from the supplier's offers. The final decision makers in the purchasing of medical devices and systems in hospitals are usually hospital administrators with a busy schedule and a modest knowledge of the technology behind the medical devices and systems. However, they carry the responsibility concerning the selection of the most suitable supplier for expensive devices and systems. In order to create an effective communication with these final decision makers, I create this tool. I have created and added weights for the evaluation factors. These weights can be entered by the decision makers to finalize the selection of the bid winner. All of what the final decision maker needs to do is to enter the weights. Based on these weights, the final scores of the suppliers will be automatically calculated in the bid. For example, in case of the availability of enough fund and resources, the quality can be stressed through the assigning higher weight values for the quality factor. Whereas in the case of immediate delivery demand of these medical devices or systems, the weight of the delivery time factor can be raised.
This is the tool which is used for the purchasing of the medical equipment. It will be used here for the purchasing of the flat panel detector. It's made up of 4 parts. The first part will be the specification. The second part will be the comparison summary table. The third part will be the running cost, and the last part will be the tender evaluation. The first part, which is for the specification. In the specification, we have 12 major points which need to be addressed by the suppliers. The second part, which is the comparison table, and the third part, which is the running cost. Part 4 and 3 should be filled by the suppliers, as we can see here. In the comparison summary table, we see that we have 5 suppliers. Their specs will be evaluated in reference to the required specification for each component of the DRF system. Then we will have the site and the pre-installation requirement, and finally the final price of the system, and the price of the options, and the total price of both the system and the options. The last part of the comparison table will be about information related to the offer, such as the validity of the offer, the warranty period, the delivery time, and the payment method. The running cost will be, or the operating cost will be the prices of the component and subcomponent of the system. For example, here we have an X-ray generator, so we will have the price of the complete X-ray generator and also the major parts of this component, such as the inverter board, the high tension tank, and so on. The last part of this evaluation tool will be the tender evaluation sheet. It can be separated into 3 parts. The first part will be the 5 evaluation factors. The second part will be the weights for these evaluation factors, and the last part will be the scores for each of the suppliers shared in this tender. The first part, which contains the values for the 5 evaluation factors: compliance with the specification, the quality of the system, the initial price or the price of the DRF system, the running cost of the DRF system or the spare parts price, and finally the delivery time. The first part, which are the evaluation factors, will be filled based on information on the comparison table and the running cost. The second part will be filled by the final decision maker, such as the hospital general manager. Here the weights can be selected based on the circumstances. We can increase the weight of each factor based on the demand. For example, in the case of needed a high quality system, can increase the value by entering 10, and we will see that all the values will be automatically calculated. So we can see here the percentage now will become different, and also the value or the score of each supplier will be different. So this is simply the purchasing tool. It's now, we can say it's now semi-automated, because the evaluation factors will be entered manually based on the comparison summary table and running cost. However, the scores will be automatically calculated. Finally, thank you, and I hope you have enjoyed this presentation.